Okay, so dear students, so hope all of you doing great. So in the previous session we completed memory management and virtual memory, and I'm assuming all of you solving the workbook questions. And remember, in the memory management and virtual memory, maybe some questions you may not solve because some additional topics also to be discussed. Okay, there are some topics like buddy system and all that. Don't worry about all that. Okay, jitna ho sake utna solve karo. I will discuss everything in the class. So I told you already, right? So don't worry about all that. So next, in the continuation, we'll move on to next topic. Okay, that is the file systems. Okay, understand here. So what is the meaning of file systems and what we are going to do in this? Let's try to understand all that. So first, let's define the file. So how do you define the file? So definition of a file. Now tell me, I think all of you studied the simple basic definition of the file. So what is the simple basic definition of the file? So file can be defined as simple definition is what? A collection of records. Okay, general definition. Okay, we say for file. But remember, okay, we discuss more technical aspect, technical definition. Okay, note down. So please keep the heading file systems and make a note. Note down the definition of the file. Definition of the file is collection of logically related entities. So entities in the sense what? Records. Okay, if you take a file, so file can be defined as this collection of logically related entities. Okay, so entities in the sense what? Records. Okay, just a simple technical definition. Now remember, if you take any file, file will have various attributes. So what attributes the file will have? Okay, note down. So file is having various attributes. Note down. So keep the heading. Okay, continue. Please copy. Okay, along with me. So file is having some various attributes. So what attributes the file will have? Okay, general attributes of the file. So I think all of you knowing this. So file name. Okay, that's the first one. And next file type. Okay, understand it. So file name, file type. Next what are the attributes we have? Creation date. Okay, so next is the creation date, and next is last modified date. Okay, so creation date and next last modified date. Next tell me, so what is the next? Owner, or you say author of the file, or you say next permission. Okay, permission related attributes like read, write, okay, and all that. Okay, so what's the next attributes? Okay, next is size. Okay, obviously size. And the next is what? Location. Okay, so this is also one more attribute, location, or you say path of the file. So these are the various attributes the file is going to have. Is that clear? Right. So they are the various attributes the file is going to have. So now if you observe here, all the attributes of the file, okay, listen here, all the attributes of the file is called as file context. Understand here. Okay, note down. Continuation, note down the statement. All the attributes of the file, copy किया ना ये सब, copy किया ना सब लोग, right? Note down. All the attributes of the file is called as a file context. Right? Now tell me, so file attributes is called as a file context. So take the process attributes is called as what? Process context. Is that clear? Right. So the file context, okay, will be stored. Okay, note down. Continuation. File context will be stored in the FCB. Okay, file context will be stored in the FCB. Okay, that is the file control block. Understand here. So file context will be stored in the FCB. Okay, that is a file control block. Note down. Okay, so now remember same thing, every file will have its own FCB. Is that clear? So har file ka apna FCB hoga, and in the FCB you maintain all the attributes of the file. Is that clear for everyone? Right. So that is about attributes of the file. That's about attributes. And next, if you take any file, okay, note down. Next, continuation. File is having various types. So please make a note. File is having various types. Now tell me what are the various types of the files we have. Dot doc file, okay, dot exe file, okay, dot dll file, okay, dot dll file, dot obj file, object file, okay, next dot class file, okay, dot class file. Next tell me what are the various types of the files we have. Okay, dynamic link libraries, okay, dot object file, exe file, class file, okay, and next simple, okay, dot okay, jpg file, okay, some picture files and all that, and next dot pdf, okay, dot pdf, and next tell me what is the Excel, Microsoft Excel version, Microsoft Excel, what is that Microsoft Excel? You have a dot XLS, and if you observe the latest version, that is a XLSX, okay, Microsoft Excel dot XLSX, okay. So they are the various types. And next tell me what are the various other types of the files we have. Okay, okay, so what are the various other types of the files we have. Okay, next dot C, okay, all your software related files, okay, simple, okay, now okay, look at it, dot C, okay, dot cpp, okay, you say dot java, okay, and next dot html, okay, dot xml, dot okay, php, okay, next okay, android file क्या होता है, android file dot okay, apk, and next dot asp, okay. So all, okay, various all software related files, there are so many files are there, okay, dot css, okay. So there are so many all software related files, okay, you can include all that, okay, that's fine. So that is about okay, various types of the files we are having. So please make a note, copy karo अच्छे से. Okay, and next what are the other types we have. Okay, let's move on. Next other types, okay, audio video files, क्या होता है बताओ. Okay, video files, your favorite, right, your favorite files, dot mp3, okay, right, dot mp4, okay, right, something like that. And next dot mkv, okay, dot avi, okay, पता है ना सबको, वीडियो ऑडियो फाइल्स, mkv, okay, avi, और नेक्स्ट you say dot 3gp, okay, right, ये तो पता होता है, right, हाँ, पूरा वीडियो फाइल से सब पता होता है, right. So understand here. So these are the various types of the files we are having. Okay, fine. Okay. So please make a copy. Note down. So all of you know this already. They are simple basics. Okay. So these are the various types of the files. Okay, we are having. And next, okay, if you take any file, okay, note down next, various operations performed on the file. Various operations performed on the file. Note down, continuation. Note down, continuation. Various operations performed on the file. Okay, so what operations okay will perform on the file. Okay, now tell me, क्या operations करते हैं आप. Okay, if you take any file, okay, you perform some various operations. What kind of operations you perform on the file? Copy कर रहे हैं सब लोग. So please copy carefully. Right. So now tell me what operations you perform on the file. Okay. Now the first one, okay, creation. Okay. So let's say creating the file. Next, now tell me, okay, after creation. So what's the next next operation you have. Okay, creation. Next is what? Open. Okay, right. हाँ, कुछ लोग बोल रहे हैं क्रिएट करते हैं डिलीट. हाँ, डिलीट आ रहा है क्या, क्रिएट करते हैं डिलीट करते हैं क्या. ओके, कुछ तो करो, राइट. सो नेक्स्ट ओपन. ओके, नेक्स्ट राइट. ओके, अंडरस्टैंड हियर. नेक्स्ट इज राइट. ओके, सॉरी, डॉट लिख रहा हूँ. व्हाई आई एम राइटिंग डॉट, आई डोंट अंडरस्टैंड. ओके, सो फर्स्ट इज okay, creating the file, and next is opening the file, and next let's say write, and next read, and next is what? Append. Okay, let's next say truncate. Next, okay, what are the other operations? File operations. Okay, simple basic file operations. Tell me what other operations you have. Save, Okay, next save as, and next rename, correct. So rename and next okay, now next now tell me, so save okay, rename, and next is what, close, okay, let's say okay, delete. So now we can write delete also, okay, right. So there are various operations on the file. Now tell me your favorite file operation. इसको भूल गया, सब लिखा है. Okay, what is your favorite file operation? Favorite file operation, copy paste, वही तो करते रहते हैं हमेशा, right? So copy, okay, so next cut, and also okay, paste, okay, and next send, okay, so also send, share and all that, and next print, okay, so print, there's so many, okay, next print, okay, so these are the various operations. Let's say edit also there. So these are the various operations performed on the file. So please copy that carefully. So these are the various operations performed on the file. Okay, so these are the various operations performed on the file. Okay, is that clear? Right. So various operations performed on the file. Copy kiya sab log? Right. Next. Now if you observe the next, okay, understand your next, file is having various access methods. Note down. So please copy this. File is having various access methods. So what are the various access methods the file is having? Okay, so note down. Okay, sequential access, and next is what, random access. Okay, so file is having two access methods. One is a sequential access and next is a random access. So sequential access means what? Accessing the file sequentially, okay, like record by record by, okay, that is a sequential access. So random access means what? Directly jumping onto the specific place, okay, so specific place. So that is called as what? Random access, directly jumping onto specific place. So that is called as a random access. Okay, so we are having two things, access method, sequential access and random access. Is that clear for everyone? And next, now tell me, you take any file, whatever the files we are having, for the better classification of the files. For the better classification of the files, files will be stored in where, okay, अगर आपको अच्छे से separate करना है, अच्छे से classify करना है, classify करने के लिए, where the files will be, okay, stored, files will be stored in the directory, okay, files will be stored in the directory. So I say directory is nothing but what? With respect to Windows के respect में बात करेंगे. So with respect to Windows, what is the meaning of directory here? Folder, okay, folder, okay. Note down, keep it as note, for the better classification of the files. Note down, for the better classification of the files, files will be stored, for the better classification of the files, files will be stored in the directory. Files will be stored in the directory. Is that clear? So for the better classification of the files, files will be stored in the directory. So note down, continuation next, okay, keep the heading directory structure. So keep the heading directory structure. Okay. Now what is the meaning of directory structure? Let's try to understand. Note down, the first one is single level directory. Note down, the first one is a single level directory. So the first we'll study, okay, so single level directory structure. So in the single level directory structure, note down, copy कर रहे हैं ना सब लोग? ओके सो मैं थोड़ा स्लो लिख रहा हूं तो इसलिए आप अच्छे से कॉपी कर सके। पैरेलल, साथ साथ में नोट्स खत्म होना चाहिए, नोट्स बनना चाहिए। ओके, जस्ट लाइक यू आर इन ए ऑफलाइन क्लास ओनली। राइट, so single level directory structure, so please copy the diagram. So let's say this is a directory, so these are the files. Okay, now understand here. So these are the directory here, and these are the various files. Okay, understand here. So single level directory. Okay, so understand what's the meaning of this. Copy kiya sab log. Now in the single level directory, okay, it means what? Okay, we are having one directory and we are storing all the files. That's it. Okay, very simple. Okay, just like you are having one folder. Okay, Windows with respect to Windows, if you talk, okay, you are having simple one. Okay, folder is there. Okay, you are having some simple folder and you are storing some files in that. Okay, that's all. So that is a single level directory. So if that is the case, what are the advantages and the disadvantages? So that's what we need to discuss. Okay, if you are having only one level of implementation, so what are the advantages and disadvantages? Now tell me the first advantage. Okay, so look at here, you are having only one level of implementation, only one level. Okay, right? So it means what? Implementation of the directory structure is what? Simple or easy. Implementation of the directory structure is simple or easy. Is that clear? Right. So note down the first point. All of you copy this. इसको copy किया सब लोग. Note down the first point. First point लिखो. Implementation of directory structure is simple. Implementation of directory structure is simple, or you say easy. Okay, right. Okay, next. Now understand next point here. Next point is now tell me, if you are having only one level of implementation, let's say you take about the Windows. In the Windows, okay, you are having one folder, and folder, okay, you are storing some files. Okay, now tell me, in the single level directory you have some problem. कुछ problem आपको दिखता है. Okay, दिखने वाला problem. क्या problem दिखता है? So which problem you can see in the single level directory? You can find some problem. Okay, problem is two files cannot have the same name. Is that clear? So that you can understand. Is that clear? Right? You can see that clearly. So if you give the same name to the file, other file, if you give the same name to some other file, it will clearly say, okay, the file already exists. Okay, so you rename the file or you say override the file. Okay, right. So understand here. So no doubt. Second point, second point, the two files cannot have same name. Two files cannot have a same name. Okay, right. Two files cannot have the same name. Next, now coming to the next point. Now I am asking the third point. Okay, third point मैं आपसे पूछ रहा हूँ. Okay, सोच के बताओ. Coming to the third point is searching time. Now think and tell me. Think about the searching time here. Okay, searching time for the specific files. Searching time for the files will be less or more. सोच के बताओ अच्छे से. ओके, एक फोल्डर है. सुनो मेरे को, सुनो पहले. सिंगल लेवल डायरेक्टरी है. लेट्स से एक फोल्डर है. सिंपल, यू आर हैविंग वन सिंपल फोल्डर एंड इन द फोल्डर यू आर स्टोरिंग द वेरियस फाइल्स देयर. एक फोल्डर है, फोल्डर के अंदर कुछ फाइल्स है. नाउ टेल मी, सो सर्चिंग टाइम फॉर द फाइल्स विल बी लेस और मोर. ओके, सो राइट आंसर इज मोर. राइट आंसर इज मोर. So searching time for the files will be more. Okay. Now remember, don't think like you are having around 10 files or 100 files in a single folder. Imagine you are having 1 lakh files in a single folder. Imagine you are having only, okay, you are having around 1 lakh files in a single folder. And remember, if you want to search any file, it will take around 2 hours or 3 hours time to search any file. It will take 2 hours or 3 hours time to search any file. Is that clear? Right? So, okay, don't think you are having only 10 files or 100 files. Okay, imagine you are having 1 lakh files. Okay, if you want to search anything, that will take around, okay, 1 hour, 2 hours time. Is that clear? Right? No doubt. So, searching time, no doubt. So, please make a note. Searching time for the files will be more. Searching time for the files will be more. Okay, right. So that is the okay problem okay in the single level directory structure. So to avoid okay this problem, okay, to avoid this problem we'll go for the next type of directory structure. Understand here. So to avoid this problem we'll go for the next type of directory structure. So that is okay, multi-level directory structure, multi-level, or you say what, a tree level directory structure. Okay, so understand here. So next is multi-level, or you say tree level directory structure. Okay, no doubt, multi-level or say tree level directory. So multi-level or tree level directory, it means what? Multi-level means what? Okay, directory inside the directory, like folder inside the folder, folder inside the folder. So please copy this. So please copy this diagram. So let's say this is a main directory. So this is a subdirectory. Okay, so understand here. So these are all what files. So please copy the diagram. So please copy the diagram. So I'm waiting 5 seconds in the live. Okay, right. So understand here. Okay, next let's move on to this multi-level directory structure. So it's very simple and you can understand easily. Okay, right. See, multi-level directory means what? Simple. Okay, just like a directory inside the directory, or you say folder inside the folder. So okay, this is the main folder and these are the subfolder and this again subfolder. Okay, something like this. Okay, these are all what? Okay, representing the files. Okay, they are the files. Representation of the files. Okay, simple. Now tell me, so if you are having multiple levels of implementation, multi-level directory structure, so these are multiple levels of implementation. Now tell me the first point. So because you are having multiple levels of implementation, now tell me, implementation of the directory structure will be, okay, what? Difficult, or you say complicated. So implementation of the directory structure is difficult. So that is the first point. Note the first point. Implementation of the directory structure is difficult or complicated. Implementation of the directory structure is difficult or complicated. Next. Now understand here. Okay, so next point. Now understand here next point. Now tell me, so if you are having multiple levels of implementation, look at here. So let's say main folder and subfolder like this. When you are having multiple levels of implementation, so if that is the case, what is the advantage? Okay, advantage of this because we are having multiple levels of implementation. What is the advantage? Advantage is okay, understand here. When you are having multiple levels of implementation, okay, the better classification of the files. The better classification of the files. इसका मतलब क्या है? Better classification of the files means you can classify the files in a better manner. You can classify the files in a better manner. It means what? Let us say you want to store the marks of the entire school. जैसे पूरा school है, school का marks आपको store करना है. So you can classify them in a better manner. Like for example, you can create a main folder as a okay marks, and again subfolder according to class wise, like 9th class marks and 10th class marks, okay, 8th class marks, like that. And you can have again subfolder according to section wise, A section, B section, something like that. And you can again you will have subfolder, okay, with respect to subject wise, like science, maths, social, something like that. Is that clear? So मतलब पूरा स्कूल का भी मार्क्स अगर आपको स्टोर करना है, you can classify them in a proper manner, okay, according to the criteria. As per the criteria, you can classify the files, okay, in a proper manner. Is that clear? So that is the second point. Is that clear? So note down second point. The better classification of the files. Note down the better classification of the files as per the criteria. The better classification of the files as per the criteria. Okay, right. So understand here. So that is the okay, next important point here. The better classification of the files as per the criteria. So next, now tell me here. Okay, coming to the next point, searching time. So searching time for the files will be less or more. Okay, searching time will be what? Less. Is that clear? Right. No doubt. Searching time for the files. Searching time for the files will be less. Searching time for the files will be less. Okay, right. Next. Now, what is the problem in this? Okay, what is the problem in this? When you are having okay, multiple levels of implementation, what is the problem here is? The problem here is if the same file exists in the two different okay, directories. If the same file exists in the two different directories, then if one file is updated, then other file has to be updated accordingly. Otherwise, there will be what? Inconsistency. इसका मतलब क्या है? इसका मतलब ये है, let's say for example, you are having a marks.doc somewhere here. Okay, fourth point you can write later. So look at here. So marks.doc. Okay, you are having some file here. Marks.doc. Okay, you are having some file there. And let us say you are having the same file, okay, in some other directory also. Let's say, okay, marks.doc, you are also having, okay, in some other, okay, subdirectory here, marks.doc. Okay, look at here, maybe because of some reason, okay, maybe because of backup and all that, because of some reason, okay, you are storing, you are maintaining the same file in the two different directories. You are maintaining the same file in the two different directories. So you maintain here marks.doc and same marks.doc here. Now in that case, remember what happens? If one file is updated, then other file has to be updated accordingly. Other file has to be updated accordingly. Otherwise, you will have what? Inconsistency problem. Otherwise, you will have inconsistency problem. Is that clear for everyone? समझ में आ रहा है सबको? Right? No doubt. No doubt. The fourth point. Okay, so first point हो गया, first, second, third, fourth. Okay, fourth point. No doubt. If the same file exists, in the two different directories, if the same file exists in the two different directories, then if one file is updated, if one file is updated, the other file has to be updated. Other file has to be updated accordingly. Other file has to be updated accordingly. Otherwise, there will be a inconsistency. Otherwise, there will be a inconsistency. Is that clear? So inconsistency का मतलब क्या है? देखो हो सकता है यहाँ पे नया मार्क्स आ गया तो यहाँ पे पुराना मार्क्स होगा. Is that clear? So या तो यहाँ पे पुराना मार्क्स है, यहाँ पे नया मार्क्स है, कुछ भी. Is that clear? Like that. So if one is updated, other one is if you are not updating, then what happens? Obviously, you will have the inconsistency problem here. So one will have the latest marks and one will have the old marks. Okay, something like that. Is that clear? So to avoid this problem, what is the problem here? Fourth point. मैं क्या बताया? If one same file exists in the two different directories, if one is updated, other one has to be updated accordingly. Otherwise, you will have inconsistency problem. So to avoid this problem, we'll go for the next type of directory structure. to avoid this problem, we'll go for the next type of directory structure. Now tell me, what is the next type of directory structure? To avoid this problem, we'll go for the next type of directory structure, that is acyclic graph. Acyclic graph directory structure. Okay, so acyclic graph directory. So that is the next type of directory structure. So acyclic graph directory structure. Okay, I think all of you studied this. So what is going to happen in the acyclic graph directory structure? So please copy this. So copy the same diagram. Copy करना पड़ेगा. You cannot modify or you cannot change. So please copy this. फिर से कॉपी करो ये पूरा कॉपी करो and add this feature. Okay, file sharing feature. Don't be lazy. I'm waiting 5 seconds in the live. मैं साइड हो जा रहा हूं, अच्छे से कॉपी करो. Okay. So fine, now understand here. So acyclic graph directory structure here. So what are the various points in this acyclic graph में क्या होता है? Okay, understand here. Okay, note down the first point here. First point acyclic graph में first point लिखो अच्छे से. Note down the implementation of the directory structure. The implementation of directory structure is difficult. Implementation of the directory structure is difficult or say complicated. No doubt. Second point. Second point लिखो. The better classification of the files. The better classification of the files as per the criteria. The better classification of the files as per the criteria. Next, okay, next point, searching time for the files. Searching time for the files will be less. Searching time for the files will be less. Okay. Next, now coming to the fourth point. Just listen here. Searching time for the files will be less. Okay, third point okay na, right? Next, fourth point. Now listen here. So first 3 points are what? Exactly same. Okay, same as your previous one, multi-level directory structure or tree-level directory structure. So first 3 points में कोई difference नहीं है, कोई difference नहीं है. But the fourth point is difference here. Fourth point is different. Okay, what happens in the acyclic graph directory structure is if the same file exists. If the same file exists in the 2 different directories, remember, if one file is updated, then the other file will be updated automatically, by using file sharing concept. Understand carefully. It means what? In this file, you will have an attribute called file sharing, and in the file sharing, you give the path of this file here. You give the path of this file here. So then what happens? Automatically the link will establish between both the files. And same thing in this file, you'll have the file sharing attribute. So in that you give the path of this file. So then automatically the link will establish between both the files. If one file is updated, the other file will be updated automatically by using file sharing concept. File sharing concept. Is that clear for everyone? Okay, so that is the meaning of that is the advantage of acyclic graph directory structure. Okay, no doubt. So please make a note. Note down the statement. If the same file exists, in the 2 different directories, if the same file exists in the 2 different directories, then if one file is updated, if one file is updated, then the other file will be updated automatically. Then the other file will be updated automatically by using file sharing concept. By using file sharing concept. Is that clear? So, if one file is updated, the other file will update automatically by using file sharing concept. Is that clear? So, that is the advantage of acyclic graph directory structure. So, that is the meaning of acyclic graph directory structure. Is that clear for everyone? Right. Okay. So, that is about various directory structures we have. So, single level, multi-level, and you say acyclic graph directory structure. So, this is there in the Unix, in the Unix, so you can find this, but generally, very less people, use it, fine. So, that is about, directory structures we have, okay. Okay. So, just listen here next, if you take any file or if you take any directory, just listen here. So, whenever you create any file, or whenever you create any directory, अगर कोई file create किया, so simple word file create करना है, you click on right click on that, desktop, and you would simply say create new file, something like that, Microsoft Word file, whatever. So, whenever you create any file or create any directory, where the memory will be allocated, जब भी आप कोई फाइल क्रिएट करते हैं तो मेमोरी कहां पे एलोकेट होगा, इन द सेकेंडरी मेमोरी, इजरली सो ऑन द हार्ड डिस्क, इजरली सो व्हेनेवर यू क्रिएट ए फोल्डर, सो मेमोरी कहां पे एलोकेट होगा उसके लिए, ऑन द फोल्डर डायरेक्टरी, सॉरी डिस्क, ऑन द डिस्क, हार्ड डिस्क के ऊपर एलोकेट होगा. समझ में आ रहा है सबको, राइट? सो इट मींस व्हाटएवर द फाइल्स यू क्रिएट एंड व्हाटएवर द डायरेक्टरी यू क्रिएट, so memory will be allocated in the secondary memory, so that is in the hard disk. So understand here. Next, so next we'll move on to the next one, that is the disk structure. Note down. Next, keep the heading disk structure. So please draw this. So I am poor in the diagrams, so please just understand. So this is the spindle, and this is generally called as what, platter, and this is read write header. So please copy carefully. So this is upper surface, lower surface. So please copy this. So please copy this. मैं साइड हो जा रहा हूं. अगर कोई समझ में नहीं आया, ओके, इफ एनीथिंग इज नॉट क्लियर, ओके, सो जस्ट लीव दैट. और कोई चीज समझ में नहीं आया तो टेंशन मत लो, उसको छोड़ दो. ओके, जब मैं बताऊंगा तब लिख सकते हो आप. Okay. Now, so understand here. Okay, next let's try to understand here. Okay, so if anything is not clear, don't worry. Okay, यहाँ पे अगर doubt है तो सुनो इधर. Okay, this called as a header or a preamble. Okay, this called as a preamble. Okay, so header means you store the address. Okay, next is what data, and here is what CRC. CRC मतलब क्या होता है? Cyclic redundancy check. Okay, अगर आप पढ़ते होंगे ना, right? CRC. So यहाँ पे लिखो क्या? Okay, CRC means okay, CRC means okay, so I write here. So cyclic redundancy check. Cyclic redundancy check. So it means that is used for what? Error detection and error, okay, correction. Okay, cyclic redundancy check. So fine. Okay, next. So that is the meaning of this. Okay. Now understand here. So this is the okay disk structure. So I am talking about what? Hard disk. Okay, so maybe in your computer. Okay, so this is a hard disk. You will have similar kind of structure. So I am just repeating. Okay, so what's the meaning of this? Okay, the answer is no. You will have a multiple platters. Multiple platters. Look at here. So it's a platter 0. Okay, platter 1, platter 2. So you will have multiple platters all combined together. Okay, on common spindle here. You will have a multiple platters all combined together on a common spindle. So look at here. So it's a platter 0, platter 1, platter 2 like this. So all combined together on a common spindle like this. And every platter will have the two surfaces. Every platter will have two surfaces. Okay, one is the upper surface and next is the lower surface. So every platter will have the two surfaces. Okay, look at here. One is the upper surface and lower surface. Lower surface nahi dikh raha hai. Okay, imagine karo, right? So okay, upper surface and lower surface. And remember, so this is the read-write header, and this will be just like a clip. Okay, clip jaisa hota hai, and it will be pointing to both the upper surface and the lower surface. So it will point into both upper surface and the lower surface. So it will be moving like this. So disk arm, okay, it will move like this. Okay, so towards forward and backward direction like this. Is that clear? Right. So that is the okay disk structure we are having. And remember, okay, मैं repeat कर रहा हूँ फिर से. You are having multiple platters all combined together on a common spindle, and every platter will have two surfaces, upper surface and lower surface. And if you observe the surface here, okay, every surface, whether it's a upper surface or lower surface, surface will look like this, and surface is divided into various tracks. Okay, listen here. So this total round one is called as what? Track. So total round one is called as what? Track. So surface is divided into various tracks, and track is further divided into various sectors. Okay, look at here. So this is a sector. Okay, next sector, next sector, next sector, like this. So track is further divided into various sectors. Okay, so understand here. So surface is divided into various tracks, and tracks is further divided into various sectors. And every sector, okay, will have the three parts. Every sector will have the three parts. Okay, one is the header, and next is the data, and next is the CRC. Understand here? So every sector will have the three parts here. Okay, every sector will have the three parts. One is a header, preamble, okay, header or say preamble, and next is a data or okay CRC. Next is CRC. So header or preamble both are same only. Header में क्या होगा? Address of the sector. And next, okay, you will have the data. And next is what here? CRC. CRC means what? That is used for error detection and error correction. CRC matlab cyclic redundancy check. So maybe if you study computer networks and some security related algorithms, okay, you will understand what is the meaning of the okay CRC. And remember, sector is also called as what? Disk block. Sector is also called as what? Disk block here. Okay, so this you should remember. Okay, so because going forward use the term called disk block. Disk block मतलब क्या है? Sector only, right? So मैं फिर से repeat कर रहा हूँ. Okay, next because next you are going to solve the question. Next you will solve the question. So please the answer सुनो इधर. Okay, you are having multiple platters. मैं repeat कर रहा हूँ, सुनो अच्छे से. You are having multiple platters. So platter 0, platter 1, platter 2 all combined together on a common spindle like this, and every platter, okay, will have the two surfaces. Every platter will have two surfaces. One is the upper surface and the lower surface. Okay, one is the upper surface and next is a lower surface. And next, every surface is divided into various tracks. Look at here, this is a surface you are having. Every surface divided into various tracks. The total round one is called as a track here. Every surface divided into various tracks, and the track is further divided into various sectors. So this is called as a sector here. Okay, so every track is further divided into various sectors, and sector will have the three parts. Every sector will have the three parts. Okay, one is a header, and next is a data, and next is a CRC. So header, data and CRC. Header is also called as what? Preamble. Okay, and next is the data and next CRC. CRC means cyclic redundancy check. So okay, so this is how the disk structure will look like. Okay, so note down the question. Question लिखो अच्छे से. Question लिखो. Question लिखो. Consider a disk. Consider a disk which has consider a disk which has 16 platters. Okay, मैं यहाँ पे लिख रहा हूँ. I am writing here. Consider a disk which has 16 platters, and each platter is having two surfaces. Consider a disk having 16 platters, and each platter is having two surfaces, and each surface is divided into 1K tracks. Each surface is divided to 1K tracks. Each surface is divided to 1K tracks, and each track is further divided into 512 sectors. Each track is further divided into 512 sectors. Each track is further into 512 sectors, and each sector can store 2 KB data. यहाँ पे लिखा है, वैल्यूज बोर्ड के ऊपर लिख रहा हूं. Each sector can store 2 KB data. Full stop. Then calculate question number 1. Question number 1. What is the capacity of the disk? Question number 1. What is the capacity of the disk? Next, question number 2. Question number 2. How many bits are required? How many bits are required to identify? How many bits are required to identify specific sector of the disk? How many bits are required to identify specific sector of the disk? Okay, how many bits are required to identify specific sector of the disk? Okay, so try to solve both the questions. Okay, simple and good questions. So try to solve the questions. I'll wait 5 seconds in the live. आप pass करो, video pass करो. Okay, right. So I think all of you, okay, so solved. If anybody is not solved, okay, you can just pause my video. Please pause my video and try to solve. So question number 1, okay, what is the right answer? Okay, now understand here. So I write here question number 1. you can simply multiply, right? So question number 1, what is asking? Capacity of the disk, capacity of the disk. So okay, 16 platter is there, 16 platter, okay, you can write what? 2 power 4, and each platter is having 2 surfaces, that is 2 power 1, and each surface is having what? 1k tracks, that is 2 power 10, and okay, each track is having how many sectors? 512 sectors, okay, that is 2 power 9, and each sector can store how much data? Okay, 2 KB data, so that is 2 power 11 bytes. Is that clear, right? So 2 power 2k means what? 2 power 11, correct? So Sailigana, right? So simply add all of that. So how much is that coming here? So 4 plus 1 5, 15, okay, 15 plus okay 20, so that's 35, correct? So 2 power 35 bytes. So 2 power 35 is how much? 32 gigabytes. 32 gigabytes. So 2 power 5 is how much? 2 power 5 is a 32 and 2 power 30 is a giga, right? So 32 gigabytes. So that is the question number 1. Question number 1, that is the right answer. Next, now question number 2, understand here what is the right answer. Okay, let's see how many of you solved it correct. So if you want to identify, okay, question number 2 में क्या पूछा है? So I'm writing here. Question number 2, what is asking? First, how many bits are required to identify the specific sector of the disk? How many bits are required to identify specific sector of the disk? So if you want to identify any particular sector, okay, first of all, what you need to identify? Platter. Okay, sector को तो दूर कब आता है, तो पहले तो किसको पकड़ना पड़ेगा, किसको आइडेंटिफाई करना पड़ेगा? Platter. So how many platters are there? 16 platters are there. So to identify, okay, one platter, to identify one platter, how many bits are required? To identify one platter, you require how many bits? 4 bits are required. So 4 bits are required to identify the platter first. So once you identify the platter, then you need to identify what? Surface. How many bits are required to identify the surface here? Okay, 1 bit required to identify the surface. Why? Because okay, you'll have the upper surface and the lower surface. Okay, 0 or 1. Okay, to identify the surface, you require 1 bit. Surface के ऊपर आने के बाद, next you need to identify what? Track. So on the surface, you are having how many tracks? 1k tracks. To identify every track, how many bits are required? 10 bits. Because 2 power 10 is 1k. So 10 bits required for the track. Next, now once you come on to the track, to identify the sector, how many bits are required? 9 bits. Because okay, 512 512 is nothing but what? 9. Okay, 2 power 9 is a 512. Okay, so these many bits are required to identify a specific sector of the disk. So how many are total? So this is 5 24, right? So 24 bits. So this is the right answer. Okay, that is question number 2. So how many bits are required to identify a specific sector of the disk? That is the 24 bits are required. Is that clear for everyone? Right. So that is the okay disk structure. Okay, with the okay simple basic questions. So remember, so disk structure, whatever I have discussed here, in the disk structure, whatever I have discussed, that is simple basic. So in the okay disk structure, whatever I discussed, that is a very simple and basic. Okay, so this actually okay one of the interesting and the big topic in the computer organization, not in the okay operating system. So actually there is something like okay disk IO time, disk IO operation time, like seek time, rotational latency, transfer time. You will have so many questions and problems. Okay, so all that you will study in the computer organization. So यहाँ पे okay in our okay operating system, whatever is required, so basic terminology like a track, a sector, okay, you call as a disk block and all that, okay, simple terminology to introduce and all that. So I told you all this okay concept. Okay, but ये सब जो भी बताया वो सब simple basic theory है. इसके बारे में पूरा in detail कहाँ पढ़ते? CO में पढ़ते, computer organization में पढ़ते. Is that clear? Right. So fine. So that is about okay disk structure. Okay. So fine. Okay. Next we'll move on to the next one. That is disk space allocation methods. Okay. So understand here. So what is the meaning of that? You will understand all that. So just wait. So I use my duster. Okay, right. Fine. Okay, so understand here. Next, okay, we'll move on to the next topic. So that is this one. Okay, important topic. Disk space allocation methods. Disk space allocation methods. Note down. So keep the heading disk space allocation methods. Okay. Now understand carefully the disk space allocation methods. Okay, what is the meaning of this? Okay, we'll understand all that in detail. Okay. Now tell me disk space means what? I'm writing something called disk space. Now tell me the final entity, batao, final entity where data will be stored. Now tell me final entity where data will be stored. What is that here? Let's say you are having platter, you are having surface, you are having track and you are having sector. So final entity where data will be stored on the sector only. And sector is also called as what? Disk block. So it means what? Whenever you create any file, कोई भी फाइल अगर आप क्रिएट करते, so कुछ स्पेस तो allocate होगा, some space will be allocated on the disk. So what is that space indirectly? Some sectors will be allocated, and sectors is also called as what? Disk block. It means what? Some disk blocks are allocated. So indirectly, so whenever the file is created, disk space will be allocated. What is that space indirectly? Some disk blocks are allocated. So what are the various different approaches? What are the various methods? How the disk blocks are allocated? How the disk blocks are allocated? So that we are going to study now. Is that clear? Right. Okay. So no doubt the first technique, okay, we are having is contiguous allocation. Noda, contiguous allocation. So what is the meaning of contiguous allocation? Let's try to understand here. So in the contiguous allocation, let's say you are having the disk like this. So please copy this. Okay. So please copy this. So these are the disk blocks. Note down this file. Please copy this. Okay, it's a starting dBA and size. Okay, that is with respect to number of disk blocks. Please copy all that carefully. So I will wait 5 seconds in the live. आप पास कर सकते हैं, वीडियो पास करके कॉपी करो अच्छे से पूरा. Okay. Now understand here. So if anybody is still copying, so please pause my video, right? And next, so the first one is contiguous allocation. Okay. Now understand here. So this is the hard disk we are having. This is a hard disk. So these are all what? These are all the disk blocks. Is that clear? See, disk blocks nothing but what? Sectors only, right? So this is a hard disk here. So these are all the various disk blocks you are having. So in the contiguous allocation, okay, whenever the file is created, in the contiguous allocation, whenever the file is created, the disk blocks are allocated in a continuous manner. Okay, in the contiguous allocation, okay, whenever the file is created, the disk blocks are allocated in a continuous manner. So continuous manner, okay, it means what? Look at here, disk blocks are allocated in a continuous manner, and every file is associated with the two parameters. Every file is associated with the two parameters. One is the starting DBA, starting disk block address, and next is what here? Size. Okay, so DBA मतलब क्या है? Disk block address. हाँ, कुछ लोग सोचता है database administrator सोचा है कि कोई लोग, हाँ सोचा है कुछ लोग, intelligent fellows. DBA means what? Disk block address. लिखो अच्छे से. So disk block address. So DBA means what here? Disk block address. Okay. Now every file is having two parameters. Okay. Starting disk block address and next is what here? Size. Okay. So starting disk block address and next is what here? Size. Okay. Understand here. So every file is having two parameters. Starting disk block address and size. So abc.doc. What is the starting DBA here? Okay. 2. And starting disk block address 2 and size is what here? 4. So it means what? Continuously 4 blocks are allocated. And xyz.doc is what? Starting disk block address 9 and size is what here? 5. So it means from the disk block number 9 and continuously 5 blocks are allocated. Is that clear? So that is the, okay, how it is going to happen in the contiguous allocation. So in the contiguous allocation, right, I am repeating. So abc.doc, okay, starting disk block address is 2. Okay, it means like continuously allocate 4 blocks. So that's disk block number 2, okay, 3 and 4 and 5. So continuously 4 blocks allocated. And next, xyz.doc, starting disk block address 9 and size is what here? 5. So it means what? Okay, now disk block number 9, 10, 11, 12, 13. So continuously 5 blocks will be allocated. Is that clear? So that is the, okay, meaning of, okay, that is how the disk blocks will be allocated in the contiguous allocation. Is that clear for everyone? Right? So if that is the case, if I allocate the disk blocks in the continuous manner, okay, as I explained just now, अगर ऐसा allocate करते आप लोग, so what are the advantages and disadvantages? So that we are going to discuss now. Is that clear? No doubt. Note down the points. एक point लिखो अच्छे से. Note down. First point, in the contiguous allocation. Note down the first point, in the contiguous allocation, whenever the file is created, whenever the file is created, the disk blocks are allocated. The disk blocks are allocated in a continuous manner. The disk blocks are allocated in a continuous manner. Okay, right. So first point, in the contiguous allocation, whenever the disk block, whenever the file is created, the disk blocks are allocated in a continuous manner. Is that clear? Right. Next. Now coming to the next, okay, coming to the next point. Okay, now every file is associated with the two parameters. Every file is associated with the two parameters. One is the starting disk block address and next is what here? Size. Okay, no doubt. Next point. Every file is every file is associated with the two parameters. Every file is associated with the two parameters. One is the starting disk block address. Number one starting disk block address. Number two, size. Number two, size. Is that clear? Right. Okay. So now tell me, so if this is the case, if the disk blocks are allocated in a continuous manner, what is the problem here? Okay, what are the problems? Okay, understand here. The answer is not just say xyz.doc. Okay, starting disk block address is 9 and size is 5. So iska matlab kya hai? From disk block number 9 and continuously 5 blocks are allocated. So that is the disk block number 9, 10, 11, 12, 13. So continuously 5 blocks will be allocated. So this is what is the happening in the continuous allocation. So if this is the case, what is the problem here? The problem is first problem is आप guess करना चाहिए. भाई बोलने से पहले आपको guess करना चाहिए. So if the disk blocks are allocated in a continuous manner, what is the problem here? The problem is if you want to increase the file size, increasing the file size may not be possible always. Is that clear? Why? Now tell me, if you want to increase the file, size, next continuous block must be what? Free hona chahiye. Like for example here, xyz.doc starting db is 9 and size is 5. So continuously 5 blocks allocate हुआ 9, 10, 11, 12, 13. If you want to increase the file size, क्या होना चाहिए बताओ? Next continuous block यहाँ पे पक्का free होना चाहिए. Next continuous block may be free or may not be free. Free हो भी सकता है, नहीं भी हो सकता है. Is that clear? अगर next continuous block free है, तो you can increase the file size. Okay, if it is not free, then it is not possible to increase the file size. Is that clear for everyone? Right? So it means increasing the file size may not be possible always. Increasing the file size may not be possible always. Is that clear? No doubt. Note down the next pointer. Next pointer. So please make note down the next pointer. Increasing the file size. Increasing the file size may not be possible always. Increasing the file size may not be possible always. Right. So that is next point. Now tell me next point here. Let us say for example, let's say some disk block here. Okay, in the hard disk, let's say disk block number 0. Example, disk block number 0 is freely available. Just an example. The answer is not just say disk block number 0 is freely available. Now I want to make use of that free disk block for this file xyz.doc. इसके लिए क्या है बताओ? Okay, यहाँ से start हुआ 9, 10, 11, 12, 13. Now इसके बाद now let's say for example disk block number 0 free है. I want to make use of this block here. Okay, so to increase the file size. Okay, इसका xyz.doc का इसके लिए increase करना चाह रहा हूँ and I want to make use of this block here. Now tell me, is it possible or not possible? Not possible. Is that clear? Why? Because that is not a continuous disk block. Is that clear? क्योंकि disk blocks यहाँ पे क्या होता है बताओ? Continuous allocate होता है. Okay. Now for example, 9, 10, 11, 12, 13 के बाद, if this block is freely available, I want to make use of that. Is that possible? Not possible. Why? Because that is not a continuous disk block. So it means what? Even though the disk block is freely available, you cannot make use of that block because that is not a continuous block. It means what? Even though memory is available, even though memory is freely available, you cannot make use of that. It means what? It is suffering from, बोलना चाहिए तुमको, it is suffering from external fragmentation. External fragmentation, yes or no, right? Memory is available but you cannot make use of that. Okay, so because that is not a continuous memory, continuous block. Okay, right? It is suffering from external fragmentation. Okay, no doubt the next pointer. No doubt it is suffering from external fragmentation. It's suffering from external fragmentation. Next, now tell me the next point here. Next point. Now coming to the internal fragmentation. Do you have internal fragmentation in the last block here? Okay, yes. Okay, now look at here. When you are allocating the 5 blocks here, 5 blocks to this file here, like for example 9, okay, 10, 11, 12, 13. Now coming to the last block here, last block, ये पक्का full होगा बोल के guarantee तो नहीं है ना, right? So this last block, okay, so may be full or may not be full, right? So ये last block पक्का full होगा बोल के कोई guarantee नहीं है. So full हो भी सकता, नहीं भी हो सकता. So it means what? Internal fragmentation may exist in the last disk block of the file. Last disk block of the file. Okay, last block में हो सकता है थोड़ा. Okay, internal fragmentation. No doubt. Next point, the internal fragmentation. The internal fragmentation may exist. The internal fragmentation may exist in the last disk block of the file. No doubt, internal fragmentation may exist in the last disk block of the file. Okay, right. So understand here. So internal fragmentation may exist in the last disk block of the file. So okay, next. Now coming to the next point. Okay, understand here. Okay, no doubt. The next point. It supports. लिखो पहले. Next point लिखो. It supports both. It supports both sequential and random access of the file. It supports both sequential and random access of the file. Okay, so understand here. It supports both the sequential and random access of the file. Okay, understand carefully. Suppose sequential and random access. So what is the meaning of this? Okay, look at here. Okay, let's say for example xyz.doc. Okay, starting disk block address is 9 and size is 5. So okay, look at here. Sequential access means what? Accessing the disk block sequentially. Like for example 9, 10, okay, 11, 12, 13. Okay, that is a sequential access. Sequentially access karna. Now random access means what? Random access means directly jumping onto the specific disk block of the file. Random का मतलब क्या होता है बताओ? Okay, directly jumping onto the specific disk block of the file. So that is called as what? Random access. So how random access is possible here? How random access is possible here? Okay, because random access is possible because we know the starting disk block address. We know the starting disk block address and disk blocks are allocated in a continuous manner. So that is the reason the random access is possible. Now tell me, simple question I am asking. Array, if you take array and linked list, okay, array supports random access, yes or no? Array, normal integer array, character array, whatever it is there, okay, in the C language. Array supports random access, yes or no? Yes. Array supports random access. Why array supports random access? We know the starting base address of the array and also we know that array contents will be stored, elements will be stored, okay, in a continuous manner, sequentially in a continuous manner. So that is the reason array supports random access. You apply some formula, okay, to go to the specific location and okay, random access is supported in the okay array. Now in the same manner here also you can apply some simple formula, same thing. Okay, look at here. So यहाँ पे random access कैसे possible होगा? Okay, you will have okay, starting disk block address. Okay, so just listen here. So you will having okay, how random access possible? So you will have two things. Okay, starting disk block address plus. So you will add the offset value and you go to what? Random access. Okay, random access. So this is the formula you follow. So starting disk block address, okay, plus okay, offset. Okay, you add some value. Okay, so then you go to the random access. Okay, example भी बताता हूँ. Okay, just know. Okay, example. Let's say I want to go to okay disk block number 5. Example same thing. Okay, look at here. So starting disk block address इसका क्या है बताओ? 9. Okay, ये वाला फाइल का 5th disk block पे जाना चाह रहा हूँ. xyz.doc. So I want to go to the 5th disk block of this particular file. I want to go to 5th disk block of this particular file. Then what you will do? You take the starting disk block address. So that is 9. And if I want to go to the 5th block, offset value will be what? 4. Because numbering will start what? Okay, 0 to 4. Is that clear? So the size is what? Okay, 5i. So numbering will be what? 0 to 4. So you will have the, okay, like this. So offset value start with a 0, right? Offset value start with a 0. So if I want to go to the fifth block पे जाना है तो offset value क्या add करोगे? 4 add करोगे. Offset value 4 add करो. So 9 plus 4, how much is that? 13. Look at here. So that is the fifth disk block of the file. देखो fifth disk block है या नहीं है? देखो fifth disk block है. That is the 13 is the fifth disk block of the xyz.doc disk file. Okay, look at here. So 1, 2, 3, 4, 5. So that is the 13. That is the fifth disk block. So इसका मतलब क्या है? Okay, random access. So you are directly jumping onto the fifth disk block of the file. Okay, now look at here. So it means you are not accessing any disk block in between. बीच में जो disk blocks है उसको access आप नहीं कर रहा है. You directly jump onto the fifth disk block of the file. So that is called as what? Random access. Okay, so please copy this. Okay, डब्बा में जो लिखा है वो formula copy करो and take that example. Take that example. You can pause my video. Right. So now understand here next point, next important point. Now tell me here. Now if I want to access the fifth disk block, बताओ, I am asking the question here. If I want to go to the fifth disk block, then how many disk accesses are required? How many disk accesses are required? Only one disk access required. If I want to go to fifth disk block, how many disk access required? Only one disk access required. Why? Because you are not accessing any disk block in between. So directly jump onto the only fifth disk block only. अगर मेरे को फिफ्थ ब्लॉक पे जाना है तो डायरेक्टली एक्सेस ओनली फिफ्थ ब्लॉक. सो ओनली वन डिस्क एक्सेस इज रिक्वायर्ड. नाउ टेल मी, इफ आई वांट टू एक्सेस 100th disk block, if I want to access the 100th disk block, okay, in the contiguous allocation, how many disk access required? Only one disk access required. Only one disk access required. Is that clear? अगर 100 ब्लॉक पे जाना है तो how many disk access required? Only one disk access required. Is that clear for everyone? Right. Okay. So that is the contiguous allocation. That is a contiguous allocation. So if you observe all the points, okay, if you observe all the points in the contiguous allocation, what are all the points here? So the first point is okay, what are the major problems here? I'm asking. What are the major problems here? First major problem is increasing the file size may not be possible always. That's the first major problem. And the second major problem is it suffers from external fragmentation. External fragmentation. Yes or no? Right? So to avoid these two problems, okay, we'll go for the next type of allocation. To avoid these two problems, we'll go for next type of allocation. So that is okay, linked allocation. Okay, note down next. So that is the linked allocation. Okay, so linked allocation is also called as non-contiguous allocation. Note down. So keep the heading. So I write properly, then it's not visible. Okay, so I'm writing in detail. So that is the linked allocation. Okay, or non-contiguous allocation. So please copy the diagram carefully. Okay. Starting this block address, and next is ending this block address. So please copy this. Okay. So I write this also. So what is this called as a? This called as a pointer to the next disk block of the file, or you say disk block address. Disk block address of the next disk block of the file. Disk block address of the next disk block of the file, or you say pointer to the next disk block of the file. So please copy carefully. So linked allocation or non-contiguous allocation. Okay. So I'm assuming all of you copied. Okay. If anybody not copied, you can pause my video and copy that carefully again. Now understand here next in the linked allocation. So what is going to happen in the linked allocation? The answer is not just say in the linked allocation the disk blocks are allocated. Linked allocation, or it is also called as a non-contiguous allocation. Simple. In the linked allocation the disk blocks are allocated in a non-contiguous manner. Non-contiguous manner. इसका मतलब आप इधर से इधर जा सकते हैं, इधर से इधर, इधर से इधर, किधर से किधर भी जा सकते हो. Non-contiguous manner. Okay, right. So, okay, in the linked allocation, the disk blocks are allocated in the non-contiguous manner, and every file is associated with the two parameters. Every file is associated with the two parameters, starting disk block address and next is the ending disk block address. Okay, they go starting disk block address and ending disk block address. It means what? abc.doc, starting disk block address is 2 and ending disk block address is what? 1. Look at here. So in the starting disk block address 2i. So in the disk block number 2, okay, you will have the address of the next block here. And the next disk block number 6. In this you will have address of the next block. In this you will have the address of the next block here. And in the last disk block you will have the null pointer /0. /0 means what? Null pointer. Is that clear for everyone? So /0 means okay, null pointer. Is that clear for everyone? Right. So that is okay. So starting disk block address and ending disk block address. It means what? In the okay disk blocks, in every disk block, some space is used here. Some space is used to store the address. Some space is used to store the address. Okay, यहाँ पे क्या लिखा देखो? Pointer to the next disk block of the file, or say disk block address of the next disk block of the file. So pointer to the next disk block of the file, or say disk block address of the next disk block of the file. Okay, so this is how the hard disk you are having, and in every disk block some space is used just to store the address. In every disk block some space is used just to store what? Address. Is that clear for everyone? Right. So understand here. Okay, if that is the case, what are the advantages and disadvantages? Okay, that we are going to discuss. So if that is the case, what are the advantages and disadvantages? Okay, that we need to discuss. So is that clear for everyone? Okay, समझ में आ रहा है सबको? Right. So understand here next that is the linked allocation. Okay, what are the points you need to write? Note down. Note on the first point. In the linked allocation, note down first point. In the linked allocation, the disk blocks are allocated note down. In the linked allocation, the disk blocks are allocated in a non-continuous manner. Disk blocks are allocated in a non-contiguous manner. Note down. Next point. Every file is associated with the two parameters. Every file is associated with the two parameters. One is starting disk block address starting this block address, and second one is the ending this block address. Starting this block address and ending this block address, right? Okay, next. Now understand here, okay, if this is the case, समझ में आया ना सबको, right? If this is the, okay, how you allocate the disk space. If this is how you allocate the disk space, what are the advantages and the disadvantages? Okay, we need to discuss. Now tell me, okay, I am asking the question, okay, you understood how the disk space is allocated and disk blocks are allocated, and if this is the case, now tell me, increasing the file size, okay, is possible or not possible here? Batao, okay, possible or not possible? Possible. Very good. Increasing the file size is always possible if the free disk blocks are available. Increasing the file size is always possible if the free disk blocks are available. Okay, example, look at here. Let's say for example, disk block number 0 is freely available here. Disk block number 0 is freely available. Now remember, if I want to make use of that disk block here, is that possible or not possible? Yes, very much possible. Look at here. Let's say for example, ये file को मैं increase करना चाह रहा हूँ. So let's say यहाँ पे, okay, you'll have a pointer. Okay, look at here. So from here, you'll simply have a pointer to this block, and you can simply make use of that free disk block here. Is that clear? So it means what? Increasing the file size, okay, is always possible if the free disk block is available. Why? Because wherever you are having free disk block, you can simply have a pointer from here to that free block, and you can make use of that. So increasing the file size is always possible. Okay, no doubt. No doubt. Next point, increasing the file size. Increasing the file size is always possible. Increasing the file size is always possible if the free disk block is available. If the free disk block is available. Okay, full stop. Next. Now coming to the next point. Okay, understand here. Next point is now coming to the external fragmentation. Listen here. Let's say this disk block number 0 is freely available. Disk block number 0 is freely available. Let's say I want to make use of that free disk block here. Disk block number 0 is freely available, and I want to make use of that free disk block. Now tell me, is it possible or not possible? Is it possible or not possible? Yes or no? Okay, yes. Okay, it means what? Okay, it is suffering from external fragmentation. Yes or no? No, there is no external fragmentation. Is that clear? So कहाँ पे भी free disk block हो आप उसको use कर सकते हैं. So there is no external fragmentation. Is that clear? No doubt. No doubt. Next point. There is no external fragmentation. There is no external fragmentation. Okay, full stop. Right. Next, now coming to the internal fragmentation. Do you have internal fragmentation? Okay, yes, obviously internal fragmentation तो होगा, right? Because last इस block में होगा हमेशा. Okay, right? Why? Because देखो यहाँ पे, okay, इधर सुनो यहाँ पे xyz.doc starting disk block address क्या है 9, ending disk block address क्या है बताओ 10. So इसका मतलब disk block number 9 में you'll have address of next one. Okay, in this you'll have address of this one, address of this one, and address of this one. So in the last disk block when you observe, ये पक्का full होगा बोल के कोई गारंटी नहीं है ना. Last disk block जो है वो full हो भी सकता नहीं भी हो सकता, right? So internal fragmentation may exist in the last disk block of the file. In the last disk block of the file. Is that clear for everyone? Right? No doubt. Note down this point. Internal fragmentation. Internal fragmentation may exist. Internal fragmentation may exist in the last disk block of the file. Last disk block of the file. Okay, fine. So internal fragmentation may exist in the last disk block of the file. Okay, right, fine. Next, now coming to the disadvantages here. So यहाँ पे क्या problems है बताओ, यहाँ पे क्या problems है आप guess करना चाहिए, मैं बोलने से पहले तुमको idea आना चाहिए. यहाँ पे क्या problems है? The first major problem is there is a overhead of maintaining the pointer in every disk block. It means what? Some space is wasted. in every disk block some space is wasted just to do store what address or say pointer. Is that clear? So देखो हर एक disk block के अंदर okay some space use कर रहे हैं, okay some space here, some space here, something like this. So for every disk block okay you are unnecessarily wasting some space just to do store the address or say pointer. Pointer मतलब address only, right? So note down. Okay, note down. There is the overhead of maintaining. There is the overhead of maintaining the pointer in every disk block. There is the overhead of maintaining the pointer okay in every disk block. There is the overhead of okay maintaining pointer in every disk block. Okay, full stop. Next. Now the next problem here is the next problem. यहाँ पे next problem क्या है? सुनो अच्छे से. If the pointer of any disk block is lost, if the pointer of any disk block is lost, then the file will be truncated. File will be truncated. इसका मतलब क्या है? सुनो अच्छे से. Maybe because of some reason ना ये pointer loss हो गया. Okay, look at here. Pointer of any disk block is lost. Okay, ये pointer अगर आपका loss हो गया. Example. Okay, now let's say you are having some pointer here. So ये pointer आपका loss हो गया. Okay, if the pointer of any disk block is lost, the file will be truncated. If the pointer of any disk block is lost, the file will be truncated. It means what? You don't know where is the next continuous block here. Okay, क्योंकि next continuous block कुछ भी हो सकता है, कुछ भी हो सकता है. So it means what? If the pointer of any disk block is lost, the file will be truncated. So truncate हो जाएगा. Is that clear? क्योंकि next continuous block कहाँ पे है पता नहीं चलेगा तुमको. Is that clear? Right. Note down this pointer. If the pointer of any disk block, note down. If the pointer of any disk block is lost, if the pointer of any disk block is lost, then the file will be truncated. If the pointer of any disk block is lost, the file will be truncated. File will be truncated. Is that clear? Right. Okay. And the next. Okay. So that's the next point. And now tell me the next. What is the next coming to the accessing of the file? Now remember this is important. Accessing of the file. बताओ सोच के बताओ. Okay. Coming to the accessing of the file. Will it support the random access here? यहाँ पे कोई random access का possible है क्या? Yes or no? Answer is no. Is that clear? Why? Because random access का कोई possible ही नहीं है. क्योंकि देखो आप इधर से इधर आ रहे, इधर से इधर जा रहे, इधर से इधर आ रहे. Okay, look at here. So example, let's say I want to access fifth block of this file. Example सुनो इधर xyz.doc का मेरे को fifth block पे जाना है. I want to access the fifth block of this file here. Then what happens? So first you access the first block. In this only you will have the address of the next disk block. You come here. In this only you will have the address of next block. You come here. In this only address of the next block. In this only you have the address of next block. So look at here. Fifth block पे जाना है. Fifth block पे जाना है. How many disk accesses are required? How many disk accesses are required? Fifth block पे जाना है. So look at here. 1, 2, 3, 4, 5. So if you want to go to fifth block, how many disk accesses are required? 5 disk accesses required. Now remember in the contiguous allocation previous वाला में fifth block पे जाना है. Contiguous allocation में fifth block पे जाना है. How many disk access required? Only 1 disk access required because that supports random access. Is that clear? But here it supports only what? Sequential access. If you want to go to fifth block, you need to access all the 5 blocks. If you want to go to 100th block, how many disk access required? 100 disk access required. Is that clear? Note down the next point. It supports only sequential access of the file. It supports only sequential access of the file. Is that clear? Right. Very good. So understand all the points. Okay, if you observe all the points, what are the major problems here? Okay, यहाँ पे major problems क्या था यहाँ पे? Major problems क्या है? Okay, now look at your major problem is there's a overhead of maintaining pointer. There's a overhead of maintaining the pointer in every disk block. There's an overhead of maintaining pointer in every disk block. That's a major problem. And the second major problem is if the pointer of any disk block is lost, the file will be truncated. So these are the two major problems here. So to avoid these two problems, okay, we'll go for the next type of allocation. Okay, now tell me, to avoid these two problems, okay, we'll go for the next type of allocation. So what is that next type of allocation? Batao, linked allocation. So to avoid these two problems, we'll go for the next type of allocation, that is okay, linked allocation. Okay, understand here. So sorry, okay, confused ho gaya. So to avoid these two problems, we'll go for what next type of allocation? What is that? Indexed allocation. Is that here? Sorry, okay, excuse me, right? Okay, so next type of allocation, that is what? Indexed allocation. Okay, so to avoid these two problems, we'll go for next type of allocation, that is the indexed allocation. So what is the meaning of indexed allocation? Okay, let's try to understand here. So please copy here. So please copy this. Okay, so please copy this. Okay, so these are the disk block addresses of the file, and okay, this is the end of the file. Okay, you can just copy this. Okay, so please copy this. मैं इससे थोड़ा साइड हो जा रहा हूँ, 5 सेकंड्स के लिए साइड हो जा रहा हूँ, 5 सेकंड्स. ओके, आप पास करके वीडियो कॉपी करो, वीडियो पास करके आप अच्छे से कॉपी कर लो. Okay, right. So I'm assuming all of you copied, right? So understand here. So coming to the index allocation. So what is the meaning of this? Let's try to understand here. Okay, the answer is no. In the indexed allocation, just listen here. In the indexed allocation, every file is associated with its own index node. Listen carefully. In the indexed allocation, every file is associated with its own index node. Now understand here. Okay, what is the meaning of index node? You will understand all that. In the indexed allocation, every file is associated with its own index node. The index node contains the disk block addresses of the file. Index node contains what? Disk block addresses of the file. इसका मतलब क्या है? Okay, look at here. Okay, now let's say file abc.doc. Let's say you are having file abc.doc and index node is what? Okay, 4. Okay, let's try to understand here. So file is what? Okay, abc.doc and index node is 4 here. So if you observe the index node 4 here, okay, if you observe the index node 4, in the index node 4, we are going to store all the disk block addresses of the file. In the index node 4, we are going to store all the disk block addresses of the file. So how the disk block address? Like for example, okay, look at here. So this disk, okay, this abc.doc, this file, okay, is having index node 4. In the index node 4, you are storing all the addresses. So abc.doc, okay, it is having, okay, using the disk block number 9, disk block number 3, and disk block number 7, and disk block number 13. Okay, so these are the addresses, all the addresses we are going to store in the, okay, index number 4 here. Okay, index node 4 here. Is that clear? Every file is associated with its own index node. हर फाइल का अपना अपना इंडेक्स नोड होगा और इंडेक्स नोड के अंदर क्या होगा? सारे डिस्क ब्लॉक एड्रेसेस अपन वो फाइल का, जो फाइल का है, ओके, वो फाइल का पूरा सारे डिस्क ब्लॉक एड्रेसेस अपन स्टोर करेंगे. Is that clear? Now remember, in the previous case, in the linked allocation, what you are doing? In the linked allocation, what you are doing? Tell me. In every disk block, you are wasting the space, okay, to store the disk block address. But here you are not doing like that. Whatever the disk block addresses you are having, okay, you store all of them in a one, okay, disk block here, one disk block, and you are calling that as what? Index node. समझ में आया सबको? राइट, मैं रिपीट कर रहा हूं फिर से. इन द इंडेक्स एलोकेशन, every file is associated with the, okay, its own index node. The index node contains all the disk block addresses of the file. Look at here, something like this, abc.doc. Index node क्या है यहाँ पे? 4 है. So disk block number 4 अगर आप ऑब्जर्व करेंगे, disk block number 4 ऑब्जर्व करेंगे, तो इसके अंदर सारे क्या होगा बताओ? सारे disk block addresses of the file होगा. So इसका मतलब वो फाइल, okay, abc.doc फाइल disk block number 9 को एक्सेस करेगा. 9 में डेटा है उसका, okay, 3 and 7 and 13 and finally is what? Okay, -1. So -1 means what? End of the file. Okay, that's the end of the file. Okay, note down. So please make the points, note down the points. In the indexed allocation, first point, in the indexed allocation, every file is associated with the its own index node. Every file is associated with its own index node, full stop. The index node contains, next point लिखो. The index node contains all the disk block addresses the index node contains all the disk block addresses of the file. The index node contains all the disk block addresses of the file. Okay, full stop. Right. So index node contains what? All the disk block addresses of the file. So if this is the case, अब बताओ सोच के, अगर आप ऐसा यूज कर रहे हैं तो what are the advantages and disadvantages? What are the problems? यहाँ पे क्या प्रॉब्लम्स हो सकता है ये आपको बताना है. सोचो अच्छे से, यहाँ पे क्या प्रॉब्लम हो सकता है. सुनो, सिंपल बात है. ओके, सिंपल है. ओके, हर एक फाइल का अपना अपना इंडेक्स नोड है. अब इंडेक्स नोड के अंदर सारे डिस्क ब्लॉक एड्रेसेस स्टोर किया अपन, बस इतना ही है. सो ऐसा करे तो क्या प्रॉब्लम्स आएगा यहाँ पे? क्या प्रॉब्लम हो सकता है? ओके, द प्रॉब्लम कम्स, द आंसर सुनो, द प्रॉब्लम कम्स इफ द फाइल इज वेरी लार्ज. if the file is very large, okay, then one disk block may not be sufficient. One disk block may not be sufficient to store all the disk block addresses of the file. समझ में आया सबको, राइट? ओके, इफ द फाइल इज वेरी लार्ज, एग्जांपल लुक एट हियर. सो फॉर एग्जांपल बहुत बड़ा फाइल है, ओके, उसके लिए बहुत सारे, फॉर एग्जांपल 1 लाख एड्रेसेस स्टोर करना चाह रहे हैं. इट इज यूजिंग 1 लाख डिस्क ब्लॉक्स, ओके, तो 1 लाख डिस्क ब्लॉक एड्रेस स्टोर करना पड़ेगा. सो टू स्टोर 1 लाख डिस्क ब्लॉक एड्रेसेस, one disk block may not be sufficient. One disk block may not be sufficient. So if the file is very large, one disk block may not be sufficient to store all the disk block addresses of the file. इसका मतलब अभी इसको इंडेक्स नोड बना दिया, ओके, इसको इंडेक्स नोड बना दिया, इसमें अंदर सारे डिस्क ब्लॉक एड्रेसेस स्टोर करने का पॉसिबिलिटी नहीं है, उतना सारे डिस्क ब्लॉक्स है. तो क्या करोगे आप? ओके, इन दैट केस यू हैव टू मेक वन मोर डिस्क ब्लॉक एज ए इंडेक्स नोड. Like for example, okay, like this block number 8. So you are making this also index, okay, index block. So again you will have a, okay, again pointer from here to here. Let's say if this is also not sufficient, okay, you make one more index node, okay. Let's say for example you are making that also index node, then again you will have pointer from here to here. So if the same thing is continuing like that, again that behaves like what? That becomes like what? Linked allocation. That again becomes like a linked allocation. Is that clear? So when the problem will come here, problem कब हो सकता है यहाँ पे? The problem will arise, okay, if the file is very large. If the file is very large, one disk block may not be sufficient to store all the disk block addresses of the file. Is that clear? So वो टाइम पे क्या होगा? ओके, दूसरा वाले को भी इंडेक्स नोड बनाओगे, इसमें भी सफिशिएंट नहीं है तो तीसरा वाला को भी इंडेक्स नोड बनाओगे. तो अगर ऐसे ही ऐसा लिंक करते जाओगे तो दैट अगेन बिकम्स लाइक व्हाट? लिंक्ड एलोकेशन. So this is the problem, okay. So okay, in the indexed allocation. So note down the next pointer. Next point लिखो, if the file is sorry, if the file is very large, if the file is very large, then one disk block may not be sufficient to store all the disk block addresses of the file. To store all the disk block addresses of the file. One disk block may not be sufficient to store all the disk block addresses of the file. Okay, right. Next. Okay, next point is what? Next point. Okay, now tell me what is the next point? Okay, this is the problem. Okay, file is very large. Again, you are having the problem here. And the next problem is what? Next problem is if the exactly opposite to this problem. बताओ opposite to this problem क्या हो सकता है? Opposite to this problem क्या हो सकता है? If the file is very small. Opposite to this, right? The file is very small. Then what is the problem here? One disk block, okay, it is waste of using. It is waste of using entire one disk block just to store the addresses. For example, अगर बहुत छोटा फाइल है, like 1 KB फाइल, 0.5 KB फाइल, is that clear, right? So इतना छोटा फाइल है, okay, 1 KB फाइल है, okay, 0.5 KB फाइल है, so very small फाइल है. So just to store one file, okay, in that case एक ही डिस्क ब्लॉक एड्रेस स्टोर करना है आपको. बहुत छोटा फाइल है, एक डिस्क ब्लॉक एड्रेस स्टोर करने के लिए तो पूरा एक डिस्क ब्लॉक को आप वेस्ट कर रहे हैं. यस और नो, राइट? अगर आपको एक डिस्क ब्लॉक एड्रेस स्टोर करना है, बहुत छोटा फाइल है, एक ही डिस्क ब्लॉक एड्रेस स्टोर करना है, एक ही डिस्क ब्लॉक एड्रेस स्टोर करने के लिए यहाँ पे एक पूरा डिस्क ब्लॉक को आप वेस्ट कर रहे हैं. इज दैट क्लियर? सो इफ द फाइल इज very small, if the file is very small, then it is waste of using entire one disk block just to store the addresses. Waste of using entire one disk block just to store the addresses. Is that clear for everyone? Yes or no? Right? Yes. No doubt. Next point. If the file is very small, if the file is very small, then it is waste of using if the file is very very small, then it is waste of using entire one disk block. It is waste of using entire one disk block just to store the addresses. It is waste of using entire one disk block just to store the addresses. Is that clear? Right. Okay. So that is the problem if the file is very very small. बहुत छोटा file है. Is that clear? Right. Now tell me, coming to the internal and external fragmentation. Okay, बताओ. Okay, do you have external fragmentation here? यहाँ पे कोई external fragmentation होगा? External fragmentation. Okay, there is no external fragmentation. Why? Because wherever you are having free disk block, अगर उसको use करना चाह रहा है, you want to make use of that free disk block, you can simply include that address here. You can simply include that address here. अगर मेरे को इसको use करना चाह रहा हूँ, okay, simply okay you include that address here. Is that clear? So simple. That's it. So okay, wherever you are having free disk block, you can make use of that. Okay, no problem. So there is no external fragmentation. Is that clear? But internal fragmentation हो सकता है यहाँ पे? Yes or no? Yes. Internal fragmentation तो होगा ही होगा last block में. Is that clear? So जब इतना सारे disk blocks में अगर आप store किया फाइल को, last block में पूरा मेमोरी फुल होगा बोल के गारंटी नहीं है ना last block में. Is that clear? So internal fragmentation may exist in the last disk block of the file. Full हो भी सकता, नहीं भी हो सकता. Right? So no doubt. No doubt. Next point. Next point लिखो. There is no external fragmentation. There is no external fragmentation, but internal fragmentation. But internal fragmentation may exist. Internal fragmentation may exist in the last disk block of the file. Internal fragmentation may exist in the last disk block of the file. Okay, fine. So internal fragmentation may exist in the last disk block of the file. Is that clear for everyone? Right. Okay. So next, okay. So that is about internal external fragmentation. Next, now coming to the next important point, accessing of the file. Okay. बताओ सोच के बताओ accessing of the file. Will it support random access? सोच लो अच्छे से. Random access, sequential access तो possible है obviously, right? Random access, yes or no? Yes. It will support sequential and random access. So पहले देखो मैं explain करता हूँ. No doubt. Next point, no doubt. It will support both sequential and random access of the file. It will support both the sequential and random access of the file. Okay, right. So understand here. So it supports both sequential and random access of the file. Okay, so that's the point. Okay, so how sequential and random access? Random access में doubt है क्या किसी को? Right? Random access में कोई doubt नहीं है. Look at here. You are having some addresses here, right? In this you are having direct addresses here. Like for example, okay, look at here. So 9, 3, 13 and all that. So look at here. 9, 3, 13, 7. Okay. Okay, so 9, 3, 7. Okay. Okay, so 9, 3, 7 and 13. Okay, let's say you are having addresses. So you'll have a direct okay address 9. Okay, you have a link address here, pointer to this. And next is what here? 3. You'll have a direct pointer to this. And next is 7. You'll have a direct pointer to this. And next 13. You'll have a direct pointer to this. Is that clear? So अगर मेरे को okay fourth block पे जाना है तो directly you go there and simply go to the direct block. Is that clear? So मतलब इतना सारे घूम घूम के इधर आने की कोई जरूरत नहीं है. So you maintain all the indexes here. Okay, you maintain all the indexes. Okay, just like addresses direct indexes है तो okay 13 पे जाना है तो सीधा इधर जाओगे. Okay, next third block पे जाना है तो third block क्या है बताओ 7. Okay, सीधा directly इधर जाओगे. So मतलब okay पुराना वाले previous blocks को access करने का कोई जरूरत नहीं है. समझ में आया सबको? Right? So it supports okay both sequential and random access of the file, sequential and random access of the file. Okay, full stop. And next now what are the major problems in this? बताओ यहाँ पे क्या problems है next? Okay, understand here. So problems बताया already. Okay, क्या problems है? Okay, you are having two problems here. Okay, if the file is very large, if the file is very large, okay, you are having the problem. If the file is very large, you are having the problem. If the file is very small, okay, then also you are having problem. File is very large, you are having the problem. File is very small, okay, then also you are having problem. Is that clear? So to avoid these two problems, okay, to avoid these two problems, okay, these problems, Unix follows the different way of allocation. Okay, Unix follows the different way of memory allocation. Okay, that is the inode, Unix inode implementation. Is that clear? So Unix follows the complete different way of allocation, that is the okay inode implementation. Is that clear? So the next in the continuation we will study so what is the Unix inode and how Unix inode okay we allocate the disk space to the files. So that we are going to continue next. Is that clear? So okay, in this session okay we studied okay, I am repeating, contiguous allocation. ओके उसमें कुछ प्रॉब्लम्स आया था, उसको हटाने के लिए किधर गया नेक्स्ट? ओके लिंक्ड एलोकेशन पे गया. इन द लिंक्ड एलोकेशन आल्सो अगेन यू हैड सम प्रॉब्लम्स. ओके उसको हटाने के लिए किधर गया? इंडेक्स एलोकेशन पे गया. सो इन द इंडेक्स एलोकेशन आल्सो यू आर हैविंग प्रॉब्लम. टू अवॉइड दैट वी गो फॉर व्हाट? okay, Unix inode implementation. So how Unix inode implementation will be done and how okay that's important actually with respect to gate, and we are going to solve all the questions related to that also. Is that clear? So that is okay disk space allocation, and in the next session we will continue with the okay Unix inode implementation, and after that remember okay in the continuation I will also discuss the workbook, okay workbook of memory management and also virtual memory. Is that clear? Make sure okay your solving and practicing is completed. Is that clear for everyone? Okay, thank you so much. Okay, so please enjoy the class and maintain proper notes, proper अच्छे से notes लिखो, because without notes okay it is very difficult okay at the time of gate exam. Now you may be understanding everything, okay, so whatever I am teaching, okay, whatever the teacher teaches definitely you will understand, but remember proper notes is required. So in my class I maintain pinpoint to the point notes. I don't speak unnecessary okay फालतू जैसे मैं बात नहीं करूंगा. Okay, to the point I will give the notes, to the point I will teach the subject, and to the point you solve the questions. Okay, after my class it is your responsibility to okay revise the notes properly and write the notes properly and solve the questions of workbook and gate. Is that clear for everyone? Right? So I am confident that okay we can solve okay most of the questions. Maybe 1% 2% questions obviously थोड़ा tough होगा, थोड़ा कुछ questions तो गलत भी है, 1% 2% गलत questions भी है. Okay, हर साल में एक क्वेश्चन या दो क्वेश्चन गेट में गलत आता ही आता है. Is that clear? Right? So okay maybe okay so you can ignore those type of questions. समझ में आया सबको? Right? So okay we'll continue with the next session. Okay, thank you so much. So keep smiling and keep learning. Right?